Goal of this video will be to get some practice on matrix addition, subtraction, scalar multiplication, as well as matrix multiplication. And for that, we are solving NCERT Class 12 Mathematics Exercise 3.2, and let's get started. So in the first problem, we are given with three matrices, A, B, and C. These are 2 by 2 matrices, and we are asked to find A plus B, A minus B, 3A minus C, A times B, and B times A. So what we can do, let's do the first problem. So 2, 4, 3, 2 is the matrix A. Add it to matrix B. Matrix B is 1, 3, negative 2, 5. And if you want to add it, you're essentially doing an element-wise addition. So 2 plus 1 becomes 3, 4 plus 3 becomes 7, 3 minus 2 becomes 1, and 2 plus 5 becomes 7. So that's the answer for the first part. If you want to do a subtraction, if instead you want to do A minus B, in that case you will do an element-wise subtraction. So let me write out the matrix real quick, and you're subtracting. So what you're doing is, let me write the answer to the second part here. So first you're doing 2 minus 1, so that will be 1. 4 minus 3 would be 3. 3 minus minus 2, 3 minus minus 2, that will be 3 plus 2, that's 5. And 2 minus 5 will be equal to minus 3, and that's the answer for the second part. The answer for the first part was 3, 7, 1, 7. Okay. Moving ahead, so these are the answers to 1 and 2. Now we have to compute 3a minus c. 3a minus c. So 3 times a, the matrix A is 2, 4, 3, 2, and you will do an element-wise multiplication in this case. So 3 times 2 becomes 6, 3 times 4 becomes 12, 3 times 3 becomes 9, and 3 times 2 becomes 6. And from that you subtract out c. So 6, 12, 9, 6 minus the matrix C is negative 2, 5, 3, 4. And again you do the element-wise subtraction. So 6 minus minus 2 is 8, 12 minus 5 is 7, 9 minus 3 is 6, and 6 minus 4 is 2. That's the answer for the third part. Next, we move on to the product of A and B, and I'll erase some of the stuff here. So if you want to figure out the product, we will use shifting the matrix a bit. So 2, 4, 3, 2, and this is the matrix A. And for the matrix B, you have 1 minus 2, 3, 5. This is the matrix B. And so the product, let's start with the first entry that would be here. So it's 2, 4, and 1 minus 2. So it will be 2 times 1, 2 times 1, plus 4 times minus 2. Okay. For the entry here that would lie in the first row and the second column, you would have 2 times 3, 2 times 3, plus 4 times 5, plus 4 times 5. Similarly, you do the same operation for all of the other two entries. So these and these combine to give you 3 times 1 plus 2 times minus 2, and for the last entry you have 3, 2, and 3, 5. So then you would have 3 times 3 plus 2 times 5, and once you compute this matrix, so it will be 2 minus 8, so 2 minus 8 is minus 6, 3 minus 4 is minus 1, 6 plus 20 is 26, and 9 plus 10 is 19, and that's the matrix AB. Now I would leave B times A as an exercise for you to try on, and let's move on to the next problem. So in the next problem, we are set to compute the sum of the following matrices, and it's just an element-wise addition. So for instance, in the first case, you have A plus A in the first row, first column entry, B plus B, then in the second column, first row, minus B plus B, minus B plus B, and then lastly you have A plus A plus A. And that will be equal to 2A, 2B, 0, and 2A. And you can also try the other parts here. So 3 is quite similar. You just need to add it. For the second part here, you will have a squared plus b squared, and then plus 2ab, plus 2ab. Then here you have b squared plus c squared, plus 2bc. Then you have a squared plus c squared minus 2ac. So a squared plus c squared minus 2ac. And then lastly, you have a squared plus b squared minus 2ab. So a squared plus b squared minus 2ab. And using identities, you can write this as a plus b whole squared, b plus c whole squared, a minus c whole squared, and a minus b whole squared. And similarly, in the last one, you would get cos squared plus sine squared, cos squared plus sine squared, so that's 1. Sine squared plus cos squared is still 1. Sine squared plus cos squared is still 1. And cos squared plus sine squared is still 1. So you get 1, 1, 1, 1. And that's it for problem number 2. Part 3 will be sort of an exercise for this problem. Let's move on to the third problem. In the third problem, you have 5 parts. I'll do part 2 and part 6 because those are the most exciting. So part 2, you have 1, 2, 3, and 2, 3, 4. So notice these are compatible matrices for multiplication. This right here is a 3 by 1 matrix, and this right here is a 1 by 3 matrix. So when you multiply both of these, you take 3 from here and 3 from here, so you get a 3 by 3 matrix as the answer. So you write a 3 by 3 matrix. So for the first entry here, you multiply 1 and 2, so you get 2, you get 2 here, and then you multiply 1 and 3, so you get 3, then you multiply 1 and 4, and then you get 4, and you can really continue like that. So 2 times 3, 2 times 2, so that will be 4. 2 times 3, that will be equal to 6. And so on, you can do 8. 3 times 2 will be equal to 6. 3 times 3 will be equal to 9. And 3 times 4 will be equal to 12. Let's do the last part of this problem. The others you can regard it as an exercise. Try whichever problems you can. And for the sixth part, you have 3 minus 1, 3, negative 1, 0, 2, and the second matrix you have is let me write it. It's a 3 by 2 matrix. So 2 minus 3, 1, 0, 3 minus 3, and 1. So this right here is a 2 by 3 matrix. And this right here is a 3 by 2 matrix. So the answer should be 2 from here and 2 from here. So the answer would be a 2 by 2 matrix. So what we can do now is take the dot product, the element-wise product of these two. So you have 2 times 3, 6. Negative 1 times 1 is minus 1. So 6 minus 1 is 5. 5 plus 3 times 3, 9 is 14. And then you can do the same thing, for for the second item here in this matrix, and you would get an answer like the dot product of 3 minus 1 3 and minus 3 0 1, and for that the answer will be minus 6. And you can do the same thing for all of these entries as well, and I hope that you will get the right answer. You can try on that, and basically the answers you will get here will be negative 2 plus 6, so that's 4, and 3 plus 2, that will be 5. So that will be your answer. You can try that on your own. Let's move forward to the fourth problem. So in the fourth problem, you're given with three matrices. And A, B, and C. Those are three 3x3 matrices, and you're asked to compute A plus B, B minus C, and to also verify that A plus B minus C is equal to A plus B minus C. So let's try that. So A plus B. So you're adding element-wise the matrices A plus B to get their sum. So 1 and 3 give you 4, 2 and minus 1 gives you 1, minus 3 and 2 gives you negative 1, 5 and 4 gives you 9, 0 and 2 gives you 2, 2 and 5 gives you 7, 1 and 2 give you 3, negative 1 and 0 give you negative 1, and 1 and 3 give you 4. Okay, so we have figured out the sum. Let's move forward to figure out B minus C. So again, element-wise subtraction. So 3 minus 4 gives you negative 1. Negative 1 minus 1 gives you negative 2. 2 minus 2 gives you 0. 4 minus 0 gives you 4. 2 minus 3 gives you negative 1. 5 minus 2 gives you 3. 2 minus 1 gives you 1. 0 minus negative 2 will be 0 plus 2, so 2. And 3 minus 3 give you 0. Great. Now you have to verify that A plus B minus C is equal to A plus B minus C. So you have figured out the matrices in the brackets till now, and now you have to perform one more operation on that. So let's figure out the left hand side, that is A plus B minus C. So you are now adding element wise from this matrix and the matrix A. So it will be a 3x3 matrix again, since we are all talking about 3x3 matrices. So again, let's do the same thing. 1 and negative 1 give you 0. 2 and negative 2 give you 0. Negative 3 and 0 give you negative 3. 5 and 4 give you 9. 0 and negative 1 give you negative 1. 2 and 3 give you 5. 1 and 1 give you 2, negative 1 and 2 give you 1, and 1 and 0 give you 1 as well. And let's compute the right hand side. The right hand side is A plus B. We have calculated A plus B, and you have to subtract C out of it. So again, it will be a 3x3 matrix, and in this case we are doing element-wise subtraction between A plus B and the matrix C that we have. So 4 minus 4, 0. 1 minus 1, 0. Negative 1 minus 2, negative 3. See, you're getting the same thing still now. So 9 minus 0 gives you 9. 2 minus 3, negative 1. 7 minus 2, 5. 3 minus 1 gives you 2. Negative 1 minus -2, so -1 plus 2 gives you 1, and 4 minus 3 gives you 1. So you have essentially verified it. The two matrices are equal. All the corresponding elements are equal in this case. Let's move on to the fifth problem. So you have to compute 3a minus 5b. So it's essentially a problem of scalar multiplication as well as matrix subtraction. So if you do 3a on this matrix, so 3a would be, so 2 by 3 times 3, 2, 1 times 3 will be 3, 5 by 3 times 3 will be 5, 1 by 3 times 3 will be 1, again, so 2 by 3 will become 2, 4 by 3 will become 4, 7 by 3 will become 7, 2 would become 6, and 2 by 3 would become 2. Great. And then let's move on forward to computing 5 times b. So you have to multiply each element of b with the number 5, and 5b would be equal to, so 2 by 5 times 5 will be 2, 3 by 5 times 5 will be 3, 1 times 5 will be 5, 1 over 5 times 5 will be 1, 2 over 5 times 5 will be 2, 4 over 5 times 5 will be 4, continuing 7 over 5 times 5 will be 7, 6 over 5 times 5 will be 6, 2 over 5 times 5 will be 2, and when you subtract them, you just see that they are the same matrices, so it would be equal to the zero matrix of order 3 by 3. So it would be 0, 0, 0, 0, 0, 0, 0, 0, 0. So 9 matrices in a square manner, in a square order. Let's move on forward. So you have to simplify this expression that they have put on for you. So it's a scalar multiplication at first. So cos multiplying with all the elements inside here, then sine multiplying with all the elements inside here. So let's do the first part. So cos times cos will be cos squared theta. Then cos times sine will be cos theta sine theta. Then you have cos theta times negative sine theta, so cos theta negative sine theta, and you don't forget to put a negative sign there. And then you have cos theta multiplying with cos theta, so you again have cos squared theta. Let's solve the second part. So sine times sine gives you sine squared. Then you doing sine theta times negative of cos theta, you get negative sine theta cos theta. Then you have sine theta and cos theta being multiplied, sine theta cos theta, and then at last you have sine theta multiplying with sine theta, so it gives you sine squared theta. Now if you add these two matrices up, you see cos theta sine theta this side and negative sine theta cos theta this side. So the answer would be a 2 by 2 matrix, but this entry would be equal to 0, and similarly minus cos theta sine theta and sine theta cos theta add to give up 0. Also, cos squared theta plus sine squared theta is 1, we know the identity, and cos squared theta plus sine squared theta here again is 1, and that's the answer is just the 2 by 2 identity matrix. Great. Let's move on forward. So we have solved problem number 6. Let's do problem number 7. In problem number 7, you have to find the matrices x and y if they satisfy the following equations. So I'll do part number 1, and let's leave part 2 as an exercise. So x plus y equals 7205, and x minus y is equal to 3003. And if you add them up, you still don't know what exactly the matrices x and y are. However, you can take into account that matrix algebra is quite analogous to real numbers algebra. So if you add these two equations up, just like you solve any real number equation, any linear equation, you would get plus and minus y would cancel each other, so you would get 2x equals and you are now adding these two matrices up. So 7 plus 3 give you 10, 0 plus 0 gives you 0, 2 plus 0 gives you 2, and 5 plus 3 gives you 8. Okay, so you have that 2 times a certain matrix equals this matrix. So you can take this 2 to the other side, so 2 here would become half right there. So you're dividing both sides by 2, so you have x equals half of this matrix. So finally you get x to be equal to, you'll get x to be equal to half of 10 is 5, half of 0 is 0, half of 2 is 1, and half of 8 is 4. So x is equal to this matrix. And you take this and put it into the expression, into the first equation that you had. So you now know the value of x, and you still don't know the value of y. And that's equal to 7025, if I'm not wrong. No, I'm not wrong. So y then equals the difference of these two matrices. So 7025 stays there, but this matrix goes on to the other side to be subtracted. So 5014. Now if you do that, you are doing again the element-wise subtraction. So 7 minus 5 gives you 2, 0 minus 0 gives you 0, 2 minus 1, 1, and 5 minus 4 gives you 1 again. So you have found y and you have already found x, and that solves the problem. Now you can solve part 2 as an exercise to brush up your skills in this regard of scalar multiplication and adding matrix equations. Let's move forward. So you have been given with an equation 2x plus y equals some matrix, and you also have been given with y, and this is a relatively simpler problem than the one that we attempted before. So you have 2x plus, and you know the value for y, so instead of writing y, you write the matrix that's been given to you. And now what you can do is you can take this matrix and if you take it to the other side, you take it to the right hand side, you're taking the difference. So 2x equals 1, 0, negative 3, 2 minus 3, 2, 1, 4. And again, you're doing the element-wise subtraction. So 1 minus 3 gives you negative 2. 0 minus 2 gives you negative 2 again. Negative 3 minus 1 gives you negative 4. And 2 minus 4 gives you negative 2. And now you have that 2 times x is this matrix. So in order to figure out the exact matrix x, you have to take half on both the sides. So you do half on both the sides, and half and 2 cancel out. So x is equal to half of negative 2 is negative 1. Half of negative 2 again is just negative 1. Half of negative 4 here is negative 2, and half of negative 2 here again is negative 1. And that's the value of x that we were looking for. So we'll continue our discussion of solving this exercise from NCERT Class 12 Mathematics in the next video. See you in the next one.